Hello everyone, welcome to today's class. This is Teacher Simon taking you through probability and statistics 1, and this is paper 5. Okay, so it is 9709/51 for May June 2025, and this is part 2 for questions 4 to 6. Question 4, they are saying every Saturday a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation 2.5 minutes. Then part A, how many competitors would you expect to have times within 1.2 minutes of the mean time? Now, in O-level, you looked at what we call bounds, right? They say this number is rounded to the nearest so and so, okay, to the nearest value. It can be maybe to one decimal place or whatever. Now here, when they say that it is within the 1.2 minutes of the mean time, that means you can have your mean here, then within 1.2, so it can stretch this side by 1.2, it can stretch this side by 1.2. You see that? Now, what we do here, I can write this as, let me just put it here. It can be, we have our mu, okay? And then we can subtract a 1.2. Then x, then we can have that mu. We also put a what? A 1.2. They said within. So within. And then the 1.2 of the mean. In your final year, you will do what we call modulus functions. This one is actually written as the modulus of x minus mu, then less than 1.2. Okay? That one is written like that. In fact, let me take this one down. It can come here. And then when we are writing this, we can say that it is probability of, you stretch from negative 1.2 less than x minus mu, then less than the 1.2. You begin from the negative this way and then the positive there. Now, when we are taking away mean from here, because we need an x in the middle here, then it will jump these signs. That means it becomes a plus. So do you see how it adds to this one? And then also when it jumps here and it comes this side, it will also add to this one here. You see that? Now, this is what we are having. Now we can standardize. So when we standardize, we shall have our mean, this one here, that is now the x value, then minus the mean, then divide by the standard deviation, which is 2.5. 2.5, then less than, this will be z, then your mean you are having here. I don't need to substitute this 32.4. So this one is going to be then the mean, then plus the 1.2, then I say minus the mean, then out of, what else do we have? We have the 2.5, sorry. Now mean disappears, of course, and then 1.2 divided by 2.5, 1.2 divided by 2.5, you get 0.48. So 0.48. Here it is a negative, and then here it is a positive. Now, when you see that this value is the same as this, but this one is negative, you just say that this one is going to be twice probability of z less than that 0.48. Okay, let me prove where it is coming from. I'm going to sketch this graph here, this bell-shaped curve. Okay, this side we have negative 0.48. This side we have 0.48 positive, and then the mean is 0. So we need the probability within this region. Okay, now the probability within this region Let me keep this one down. In fact, here we have to subtract a 1, okay? We have to subtract a 1, sorry. Now, for me to get what is inside here, that means I'll get the whole of this less than the 0.48, then minus less than the negative, not so. So it will be probability of z less than the 0.48, then minus probability of z less than negative 0.48. Okay, now this one, if it is less than the negative here, yeah, then it is the same as greater than the positive. It is the same as this region here. You get that? So this simply implies that we can have this one as probability of z less than 0.48, then minus probability of z greater than 0.48. Now, if you have probability of z greater than 0.48, this one here, this one will be 1, then minus probability of z less than the 0.48. Okay, 1 for the whole, then minus this other one here for the less than. You get that? And in our normal distributions, in the normal distribution table they give you for the less than. Now, when I open brackets here, that means we are going to have probability of z less than 0.48 minus 1, then plus probability of z less than 0.48. Also, do you see that this plus this gives you this, and then minus 1? So the moment you have, they are not going to ask for all of these ones here. The moment you have this, okay, you can just write this down twice, the probability of z less than the z value here, then minus 1. Or you can use a calculator, you just get this one straight away, or you read from the table. And also, by the way, this one is given for the minus on the normal distribution table. They give it as 1 minus the phi of z. You see that? Okay, now we can use a calculator to get this value here. So if you have this calculator, you will press mod and then you press option 3, which is start. Okay, so we press 3, then those ugly things come on our screen. You press that button SC, which has off. Okay, now start will come on your display. Then from there, you can press shift and then you press 1, button 1. It is the one that has start and distribution. You press button 1. Now, you see all of those that have come on the screen. You choose option 5, which is for normal distribution. So I choose 5. P, the one you're seeing there, is for less than. R is for greater than. Then Q is from the middle, 0 to a Z value. But I want less than, so I'll choose P, which is option 1. Then I put that 0.48. That is 0.68439. 2 times 0.68439. If you read from the table, this one will give you 4 decimal places. In the table, they give you up to 4 decimal places, so it will be like 6844. Okay, then minus 1. Let's check what we get from the table. So from the table here, we are supposed to look for 0.4, then 8, which 8 is here. So do you see that we are getting 0.6844? 0.6844. That is the one. So that's exactly what I've told you that you're going to have. Now we multiply this by 2 and then we subtract a 1. So I'll come to this one here and then I multiply it by 2. Then after that, I subtract a 1. So I get 0.36878. 36878. And then the expectation here is going to be because they said how many competitors would you expect. You get the probability then times the number of the competitors. Okay, so expected number of competitors shall be equal to 0.36878, then times 600. Okay, the number of competitors were 600. So what do we get here? The answer we have here, then times 600. We get 221, then 268, 221.268. So either you can write your answer as 221 or 222, because you don't have a 0.268 as a competitor. A person is whole, okay? But the most appropriate one would be what? The smaller one, which is 221. But in the exam, please don't write this 221, then all 222. No, just write one answer. Any of them is what? Correct. Then, here they are saying, in this Saturday's event, 60% of the competitors had times less than 36 minutes. Part B, 9 competitors who took part in the Saturday's event are selected at random. Find the probability that at least 2 and fewer than 8 of these competitors had times less than 36 minutes. Now, this is a binomial distribution. Why is it a binomial distribution? We can see that n is fixed. Okay, so because n is fixed and our n is 9, our p, the probability of getting the success, is 60%, which is 0.6. That means the probability of getting the failure is going to be 1 minus the 0.6, which is going to give us a 0.4. The word at least, what does it mean? At least means we have greater or equal. So the least you are going to have is 2, not so? So means greater or equal. Now, we are finding probability of x. No. We have 2 less than or equal to x, then less than what? 8. So this one is going to give us probability of x is equal to 2, then probability of x is equal to 3, probability of x is equal to 4, probability of x is equal to 5, then 6, then 7, very many. And then what? Probability of x is equal to 7. So all of these ones, we are supposed to get them and then we add them. But you can also look at 8 is not included, so 2 is included. We have something like this. There is a 2 here and then 8. So 2 is inclusive, but 8 is not. So that means if I have my 9 here, then there is a 0, then 1. So I can say 1, because total probability is 1, then minus probability of x is equal to 9, x is equal to 0, x is equal to 1, and x is equal to 8. I will be getting all that is there. That is another way to do that. Okay. All right. So what do we have here? This one will be our n is 9, then combination 2, then 0.6 squared, and then this is 0.4. This will be a 7, right? Because when you add these two, they give you the n. Then plus, we shall have, let me just duplicate this. No, I'll have 9 combination 3, then 0.6, 3, then 0.4, then 6, then 9, 4, then a 4 here, and then a 5 here. Then 9, 5, 0.6 power 4, 5, 0.4, then power 4. Then 9 combination 6, 0.6 power 6, then 0.4 power 3. Then lastly for 7, it is 9 combination 7, and then you have 0.6 to the power of 7, and then 0.4 to the power of 2. Now we put everything in the calculator, and then we get our answer here. So we have 9 combination 2. 9 combination 2 is 9 times 872 divided by 2. That one will be 36. So we have 36 times. Then we have 0.6 squared, then times 0.4 power 7, and then plus 9, then combination 3, then times 0.6, which is power 3, then times 0.4, which is power 6, then close the brackets here, then plus the next one is 9 combination 4, then times 0.6, which is to the power of 4, then times 0.4, which is to the power of 5, and then we close, then plus 9 combination 5 times 0.6 power 5, then times 0.4 power 4, and then we close the brackets. Then we go to 9 combination 6, then times, okay, let me first remove this. So I'm going to 9 combination 6, so I first press equals here, I get that, then plus 9 combination 6, then times 0.6 power 6 times 0.4 power 3, then lastly 9 combination 7, then times 0.6 power 7 times 0.4 power 2. So altogether we get 0.926 to 3 significant what? Figures. As simple as that. Alternatively, remember I told you you can have this probability of 2 less than or equal to x less than 8. It can be equal to 1 minus then probability of what is left out, x is equal to 0. Another one, x is equal to 1. 2 is inclusive. Then plus 8 here is not included. So I'll have probability of x is equal to 8 here. And then the other one is probability of x is equal to what? To 9. So let's check this one out. 1 minus, this will be 9 combination 0. Then times 0.6 power 0, then 0.4 power 9, then plus 9 combination 1, and then 0.6 to the power of 1, then 0.4 to the power of 8. Then for 8, it will be 9 combination 8, then 0.6 power 8, then 0.4 power 1, and then lastly, it is going to be 9 combination 9, then 0.6 power 9, and then 0.4 power 0. You see that? So all of these ones here, then we subtract from a 1. So let's put everything there, and then we subtract from a 1. 9 combination 0 is 1. Then 0.6 power 0 is also 1. So here we shall have 0.4 power 9. Okay. Then the next one shall be 9 combination 1, that is a 9, times 0.6, then times 0.48 power 8. Then plus 9 combination 8 is a 9, then times 0.6 power 8, then times 0.4 power 1, then plus 9 combination 9 is a 1, and what we are left with here is 0.6, then to the power of 9. Now this one here, oh, there is a 0.48 instead of 0.4. So if I take that off, this is what I'm having. Then subtract this from 1. So 1 minus the answer, 0.926. 0.926 to 3 significant what? Figures. That is that. Part C, 80 competitors who took part in this Saturday's event are selected at random. Use an approximation to find the probability that more than 50 of these competitors had times less than 36.0 minutes. Now, for greater than 50, when they say use a suitable approximation, we move away from the binomial to the normal, okay? Because we are supposed to find probability of x greater than what? 50. That means you're going to have 51, 52, 53, 54, 55, up to 80. When will you finish? So it becomes a little bit hectic, right? Now, what we are going to do here, we approximate the binomial to the normal distribution. But for the normal distribution, we need mean, okay? So mean is equal to NP. Our N is 80, and then the P is 0.6. It was given as 6%. I mean 60%. 8 times 6, that is 48, okay? And then the standard deviation, which is root of variance, and variance is given as NPQ. Then you will have square root of 80, then times 0.6 times 0.4. So I'm just going to multiply these ones such that I get the exact value. So 48 then times the 0.4. 48 times 0.4, that is 19.2. So it is root of 19.2. Now, here let me write a statement here. To approximate a binomial distribution to normal distribution, we carry out continuity corrections. Why are we doing that? For binomial, we are dealing with discrete random variables, and then for normal distributions, we deal with continuous random variables. So there has to be that continuity in the figures. Now remember, in your O-level, you did what we call error bounds, okay? So this number 36 doesn't just start from here. There is a 35 here, and then there is a 37 here, okay? So let me write it smartly. We can have 36 here, then we have 37 as the next one in line, then this is 35. But 36 starts from here at 35.5 and then ends here at 36.5. This being the upper bound, this one being the what? The lower bound. Now, this is the region we are considering here. That means when they say greater than, actually it is more than 50. Probability that more than 50, so I'm supposed to use 50. Oh my goodness. Let me check everything here. Pardon me. So this one will be a 50, then this will be 50.5. This will be 51. And then this will be 49. So this will be 49.5. Now, when we round off all of these numbers, they give us 50. Okay? And also here. But we are supposed to look at that region whereby when we round off, we get more than 50. Okay? Then it has to be here. So you either use this one or this one. Okay? It is either the lower bound or the 50 or the upper bound. Now, when I round off this 50.5, I will get 51, which is greater than what? The 50. And I have already said that if they give you greater than, you just add the 0.5 if the number is a whole number, okay? Like this one, it's a whole number. Then if it is greater than or equal, then you will subtract a 0.5. Then for less than, you subtract a 0.5. And for less than or equal, you will add a 0.5. You keep this in mind. That is that. So for this case, then we are going to standardize. And standardizing, we have Z. And this one is therefore going to be Z greater than 50. That is the x minus. Remember, Z is equal to x minus mu out of the standard what? Deviation. So this one we shall add a 0.5. You see that? Then subtract. We shall use the upper bound here. If you don't carry out continuity corrections here, you are going to get it wrong. Carrying out continuity corrections is to get the bounds of that given number, either the upper bound or the lower bound. Okay? So that the number now becomes continuous. You remember what we call class boundaries when you are dealing with statistics. So here we use boundaries. Okay, then minus, what is our mean is 48. Then we divide by the square root of 19.2. So meaning we have probability of Z greater than, this is 50.5 minus 48 out of the square root of 19.2. So I'm going to put this one in the calculator straight away and then I get the answer. Remember, we press mod, then option 3 for start, then we press SC, then you press shift, then 1, and then you get the distribution there, which is option 5. Now I told you P is for less than, this is greater than, so we pick R, put option 3, and then here we are having 50.5, we subtract 48, okay? 50.5 minus 48. Then we divide by the square root of 19.2. Like that. I close the brackets. I get 0.284. 0.284 to 3 significant figures. That is that. Question 5 is coming from combinations. In a group of 20 musicians, there are 9 guitarists, 6 pianists, and 5 drummers. 6 musicians are selected from these 20 to perform at a concert. Part A. Find the number of different ways in which the 6 musicians can be selected if there must be at least 3 guitars, at most 2 pianists, and exactly 1 drummer. Now, at least we say it is greater or equal. at most is less than or equal. Okay, now let's look at the scenarios. We are having guitarists, okay? Then we have pianists, and then the drummers. So at least means greater or equal. So if I start with a 3 and then a 2 here, exactly one drummer, so drummer has to be there. Then if these ones are 4, because that is greater than 3, and then we have a 1 here, then this one has to be a 1 here, because they have to be 6, remember. Okay, any other, these ones can be 5, and we must have one drummer. That means this one can be 0, you see, and that is all we have. So that means we shall say 9 combination 3, because we have 9 guitarists, not so? Then times, so I'm looking at the first one here, 9 combination 3, then times 6 combination 2, then times the drummers are 5 combination 1. Then I go to the next one, we have 9, then combination 4, times 6 combination 1, then times 5 combination 1. And then lastly, we have 9 combination 5, then times pianists are 6, then combination 0, and then drummers are 5, then combination 1. So this one will give us 9 combination 3, then times 6 combination 2, times 5 combination 1 is a 5. So we get 6300. 6300. The next one, I'll just come to this, and then I say 9 combination 4, and then 6 combination 1, which is a 6, and then 5 combination 1 is also a 5. So that is 3780. 3780. And then lastly, 9 combination 5 is the same as 9 combination 4. So long as these two numbers can add to the n that is here, then they will always give the same value. 9 combination 5, then 6 combination 0, that is a 1, and then times the 5, so that is 630. Now adding these all together, what do we get? 6300 plus 3780 plus 630. That is 10,720. 10,720. That is that. Then here they are saying 3 bands will be selected from the original group of 20 musicians. Each band will consist of 3 guitarists, 1 pianist, and 1 drummer. No musician can be in more than 1 band. The first band selected will play at a concert in France, and the second band selected will play in Italy, and the third band selected will play in Spain. Part B, find the number of different ways in which these 3 bands can be selected. Okay, this is what we do here. Now, first of all, we have 9 guitarists, right? We have 6 pianists, and then 5 what? Drummers. Now, in the first band, we are supposed to have how many of them? They said each band will consist of 3, 1, 1. Okay? No musician can be in more than 1 band. So, 3 guitarists, that means we can have 9, then combination 3. Then 6, out of the 6 pianists, we need only 1. And then out of the 5 drummers, we need only 1. Okay? Now, this one here will be our first band. Our first band selected. Okay? Now, next, since we have gotten 3 from here, we are remaining with how many? 6 guitarists. Now, 6 guitarists. Then combination, we need 3. Then here we took out 1, so they are remaining 5. Okay, combination, we need 1. And then here they are remaining 4. Okay, 4, we also need 1. This will be our second. And what did I write here? First is not ST. It is, oh, by the way, it is second band. Then out of the 6, we have taken out 3. That means we need 3 that are remaining to go into that group. Okay, then here we are remaining with 4. So 4, combination 1. And then here we shall get 3 that are remaining, then combination 1. This will be our third band. So what do we get here? 9 combination 3, then times 6 combination 1 is 6. 5 combination 1 is 6. I mean 5. That is 2520. So 2520. Then this one here is going to be 6 combination 3, then times 5 combination 1 is 5, then times 4 combination 1 is 4. That is 400. And then here we have a 1 times 4 times 3. What do we get? That is a 12. So then our final answer will be that 2520 times the 400 times the 12. You don't add them because you are keeping on choosing. You are choosing these ones which are remaining. These are all possible combinations that we can have. This one goes into the first band, then second band, then third band. So it goes all together. Okay, 2520 times 400 times 12. What is that? So that is 12 million, then 96,000. 12,096,000. That is that. Question 6. A bag contains 10 marbles, of which 4 are red and 6 are blue. 4 marbles are selected from the bag at random without replacement. The random variable x denotes the number of blue marbles selected, but A shows that probability of x is equal to 2 is 3 out of 7. Now there are 2 methods you can use here. You can use a tree diagram, but this one is going to be big because you have red, blue. If there are how many marbles? 4. So you have here, you have here, you have here. So it is going to be a big thing. Okay, it will be wasting your time. You can use combinations here, but I'm going to do both. Let me see the space that we have. Hopefully it can accommodate us. Let me first use that one of what? The tree diagram. So we shall have red and then blue, then red, blue, red, blue, red, blue. Those are 4. Even here, red, blue, red, blue, red, blue, red, blue. Then this one, red, blue, red, blue, red, blue, red, blue, red, then blue, red, blue, red, blue. Very big. See? Okay, so the probability of picking a red is, I think it is 4. So 4 out of 10. Then blue will be 6 out of 10. We are picking without replacement, so that means totals keep on reducing. So here we shall have 5 over 9, 4 over 8, 3 over what? 7. That means here we shall have 4 over 7. Not so. And then here 4 over 8. Then here 3 over, no, it's not 3, it's a 4 over 9. Now we have picked already a red. That means here we shall have 3, but over 8. That means this one will be 5 over 8. And then blue, then another blue here. This will be 4 over 8. And so, no, over 7. And then this will be 3 over 7. Then this is a red. Again, this one will go to a 2 over 7. Then this is 5 over 7. And then here we shall have 3 over 7, then 5 over 7. This will be 3 over 9. This will be 2 over 8, and then 1 over 7. Not so? That means this is 6 over 7. This is 6 over 8. This one will be 6 over 9. Now, let's go to blues here. This will be 5 over 8, then 4 over 7, then 3 over 7, and then this will be 3 over 8, since this one is 5 over 8. And then red. So if this is 3, then this will be 2, but then over 7, then 5 over 7. Then blue. So this one will be 5 over 7, then 2 over 7. That will be the tree diagram. So we want to get to what? We want to get 2. So probability of x, which is equal to 2, is going to be, we are seeing 2 what? 2 blues. 2 blues. So we are having 2 blues. That means even the reds are what? Are 2. So here there are many. Red, blue. Red, blue. You see that? Then there is red, blue. Red, blue. Then there is red, blue, red. You see that? Red, blue, red. Then there is blue, red, blue. Blue, red, blue. What else? There is blue, red, blue. We are done. Blue, red. So blue, red. Then there is blue. Then red. Blue, red. You see? Those are the ones you are having there. So that means we are going to have, first of all, now to avoid all of this, you can look at blues. Blues, the rate of picking a blue first here is 6 over 10. So whether you pick the blue on the second time, or on the third, or on the fourth, okay, the next probability of you picking a blue will be 5 over 9. So blues reduced by 1. Okay, yeah, I'll just write 5. Blues will be 5. So the totals keep on reducing. Okay, then when we go to reds, this is 4. Okay, 4. Then I will put over 8. Totals keep on reducing, remember? And then the next one will be 3 over what? 7. Then from here, I multiply by 6, which comes from here, which is the same as 4 combination 2. Okay, out of the 4 pickings, you are getting what? 2 blues. You get that? So let's put this in the calculator and we see what we get. 6 out of 10 times 5 out of 9 times 4 over 8 times 3 out of 7 times 4 combination 2, 3 over 7. That's exactly what we are having here. Alternatively, and this one is the easiest. Okay, alternatively, that is even what I'm going to use for part B. We are getting probability of x which is equal to 2. Blues, how many are they? They are 6. So out of the 6 we need 2. So you say 6, then combination 2, then times, because we are choosing at random, then times reds are how many? They are 4. Even these ones we shall choose 2, because remember you are picking 4 marbles. So 2 plus the 2, you will get what? The 4. Then divide by, the total is 10. Out of the 10 marbles, you are picking 4. So the sample space is, out of the 10, you are picking 4. We don't know which color that you are choosing. So when we put this in the calculator, what do we get? 6 combination 2 times 4 combination 2. We divide by 10 combination 4. It's 3/7. As simple as that. Part B, draw up the probability distribution table for X. So when you are picking these blues, you can fail to get a blue. That means all of them are what? Are red. So I can begin with X is equal to 0, no blue. That means out of the 6 reds we have, okay, let me begin with the blues. Blues are how many? They are the ones that are 6, pardon me here. So out of the 6 blues, we are picking none. But out of the 4 reds, we are picking all of them, because remember the total has to be 4. And then we divide by 10 combination 4. Okay, what do we get here? 6 combination 0 is a 1. 4 combination 4 is also a 1. Now what is 10 combination 4? That is 210. So that means here we have 1 over 210. Now when we get 1 blue, that is 6 combination 1, then times out of the 4, that means we shall pick 3 reds to make a total of 4. Then 10 combination 4. What do we get here? So this one here, 6 combination 1 is a 6, then times 4 combination 3, that's a 4. So 6 times 4, that will be 24. Then out of 210. That one can be simplified. Then we can go to the next one. Probability of x is equal to 2, we know it. Okay, then what is probability of x is equal to 3? That one can be 6 combination 3, then the next one will be 4 combination 1, then out of 10 combination 4. 6 combination 3 is what? Then times 4. Combination 3, that is 20, then times 4, 80. So I'll have 80 here out of 210. And then I can also get all of them, the reds. I mean the blues. That is the one you are going to get here when you multiply. So we have out of the 6, we are getting all of them. And then out of the 4 reds, we get none. And then 10 combination 4. So this is out of 210. And 6 combination 4 is what? Because 4 combination 0 is a 1. 6 combination 4 is a 15. That means we can now draw our table here. We have x and then probability of x equal to x. So we have 0, we have 1, we have 2, we have 3, and we have 4. So probability of x is equal to 0 is 1 out of 210. For 1, it is 24 out of 210. For 2, it is 3/7, simplified. Then 3, it is 80 over 210. And then 4 here is 15 out of 210. All of these ones can be simplified, okay? But they didn't say that we simplify them, okay? So let me put them in a table. So that is that. Then part C, find the probability that at least 2 of the marbles chosen are blue, given that at least 1 red and at least 1 blue marble are chosen. Now here we are having probability of at least 2 of the marbles chosen are blue. So we can have 2 blue and also 3 blues. You get it? And at least 1 blue marble. You get it? So we must have 1 blue marble. Then given that at least 1 red. So if we have at least 1 red, so we are going to have greater than or equal to 1. So we can have 3 blues and 1 red. Are we there? Then we can have 2 blues, then 2 reds. And we can also have 1 blue and what? 3 reds. You see that? This one is going to give us 2 blues. What do we have? For 2 blues, it is 3 over 7. It is 3 over 7. Then plus 3 blues, we are seeing 80 over 210. 80 over 210, which is the same as 8 over 21. And then down here, 3 blues and 1 red. 3 blues are here. That means there is 1 red. That is 80 out of 210. And then 2 blues, 2 reds. That is 3 over 7. And then we have 1 blue, 3 reds. 1 blue is 24 out of what? 210. 24 out of 210. So we put everything in the calculator and then we get our answer. 3 out of 7 plus 8 out of 21. Then we go down again, 3 out of 7. Then plus 8 out of 21. Then plus 24 out of 210. So we get 85 out of 97. 85 out of 97. You can write your answer to 3 significant figures or you leave it there. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.